Hey there, ready to bend your mind a little?
Always up for a good mental workout.
Today we're tackling a question that's pure science fiction gold, but also like real physics. Can anything actually travel faster than light?
The ultimate speed limit, right?
Exactly. We're diving deep into a document literally called Can Anything Travel Faster Than Light?
Straightforward title.
Which is perfect because that's exactly what we're doing. We're going to unpack why light speed is that limit, what happens when you try to get close to it, and are things like wormholes or warp drives even remotely possible?
Big questions.
Huge. But first, let's set the stage. When we say the speed of light, what are we actually talking about?
Well, it's literally the speed that light travels in a vacuum. A seriously mind-blowing 299,792 kilometers per second.
Okay, so translate that for us non-physics folks.
It means light could circle the Earth over 7 times in 1 second.
Whoa.
Yeah. It's why even though the sun is 93 million miles away, its light gets to us in about 8 minutes.
Okay, so that's fast, obviously. But WHY, is that the speed limit? Like, is there a giant stop sign somewhere in space?
Not quite. Einstein's theory of relativity is the key here. As something with mass tries to go faster, it takes more and more energy to keep accelerating. And as you get close to the speed of light, that energy requirement just explodes.
So it's like pushing a car uphill. The steeper it gets, the harder you have to push.
Yeah, kind of. Except imagine the hill gets infinitely steep the closer you get to light speed.
Okay, so no matter how hard you push, you can't quite get there.
Exactly. Einstein's equations basically say that reaching light speed would take infinite energy. And infinite energy, well, it doesn't exist.
So no light speed joyrides for us. But hold on, light itself obviously travels at the speed of light, and it seems to do it just fine.
Right. And that's because light is made of photons, which are massless particles. That's their free pass to zoom around at light speed. No infinite energy required.
So are there any loopholes in physics that could maybe let us bypass this whole speed limit thing? Our document does mention some pretty wild ideas.
One is the tachyon, a hypothetical particle that always travels faster than light.
Always.
Always. But here's the catch. They've never been observed, and if they did exist, it'd mean effects could happen before their causes.
Whoa, so time travel paradoxes right out of the gate.
Exactly. More like science fiction than science fact at this point.
Speaking of science fiction, what about warp drives? They're all over shows like Star Trek. Could those actually work?
Warp drives are cool because they don't try to break the speed of light directly. Instead of speeding up the spaceship, you manipulate space itself.
Okay, I'm intrigued.
Imagine warping space around the ship, creating a sort of bubble that can travel faster than light without violating relativity.
So like folding a piece of paper to bring 2 points closer together.
Exactly. But here's the catch. Warp drives would need something called exotic matter, which has negative energy density.
Negative energy density. Okay, now we're getting into some seriously weird territory.
Think of it this way. Everything we normally experience has positive energy density. It takes up space. Exotic matter would theoretically have negative energy density, meaning it would actually push space apart.
So it's like anti-gravity stuff.
You could think of it that way, but the problem is we've never actually found any evidence that exotic matter exists. It's still completely hypothetical.
Okay, so warp drives are super cool, but we need this mysterious ingredient that might not even exist. What about wormholes? Those cosmic tunnels that connect distant points in space-time? Those seem like another way to bypass the speed limit, right?
Right. If wormholes exist, they're like shortcuts through space-time, allowing you to travel insane distances faster than light could through normal space.
So step into a wormhole and pop out on the other side of the galaxy.
Exactly. The problem is creating and stabilizing a wormhole is, well, a bit beyond our current capabilities. We'd need to control gravity on a level that's unimaginable right now, and again, the energy requirements would be absolutely mind-boggling.
So wormholes, same problem as warp drives. Great concept, but the practicality is a bit out there. It seems like even if faster than light travel is possible, the challenges are enormous.
You got it. And those challenges are exactly what our document digs into next. Even if we did figure out the physics, the sheer amount of energy we'd need is more than anything we can currently grasp.
How much are we talking?
We're talking about more energy than our sun produces in a year, and that's just for one trip.
Wow, that puts things into perspective.
And then there's the issue of causality paradoxes.
Time travel headaches.
Exactly. If we could travel faster than light, it might be possible to travel back in time. And that could create all sorts of logical nightmares. What if you could send a message to your past self?
It'd mess everything up, right? Like change the entire course of history.
Potentially. It could unravel reality as we know it.
So maybe these paradoxes are the universe's way of saying, nope, not going to happen.
It's a fascinating thought. But even if exceeding light speed might be a long shot, there are other promising ways to explore the cosmos.
Okay, now you're talking. What kind of alternatives are we looking at?
One possibility is nuclear-powered propulsion.
Using nuclear reactions to power spaceships.
Exactly. We could theoretically reach significant fractions of the speed of light that way.
Still insanely fast.
Absolutely, like 10% the speed of light, which would make interstellar travel within a human lifetime a real possibility.
Okay, that's still mind-blowing. What else?
Another cool area is light sails.
Like spaceships with giant sails.
Yeah, huge, ultra-thin sails pushed by incredibly powerful lasers. There's this project called Breakthrough Starshot that's exploring this, aiming to reach speeds up to 20% the speed of light.
Wow, are they serious?
They believe a tiny probe could reach Alpha Centauri in just 20 years using this tech.
That's amazing. It seems like we don't have to break the speed of light to do some pretty incredible space exploration.
Exactly. And for those really long journeys, there's another crucial piece of the puzzle, artificial intelligence.
AI for spaceships.
Think about it. Even traveling at a fraction of light speed, interstellar trips would take years, maybe decades.
True.
That's where AI comes in. Advanced AI could manage the spacecraft, make decisions, handle unexpected situations, even learn and evolve during the trip.
So like a super smart robot crew.
Pretty much. It'd make those long-duration missions much more realistic.
But you know, we've been talking so much about the science, I think we need to shift gears a bit.
To the bigger picture.
Exactly. What would faster than light travel actually mean for humanity? Those are the really mind-blowing questions.
Yeah, and that's where things get really interesting. So we're going to take a quick break, but when we come back, we're diving into the profound philosophical implications of breaking that ultimate speed barrier. Stay tuned.
So we've been talking about the science behind faster than light travel, or at least the hurdles in front of it. But what I really want to get into are the big what-if questions.
The really fun stuff, right?
Exactly. Let's say, just for fun, we do crack the code. What does that even mean for humanity? Our document went into some pretty wild philosophical territory.
It gets pretty deep, doesn't it? Faster than light travel wouldn't just be a new technology. It'd be like rewriting our entire understanding of, well, everything.
It's hard to even imagine. We're talking colonizing other planets, meeting aliens, maybe even messing with our perception of time.
It'd be like stepping off the edge of the map into completely unknown territory. Think about what it could do to our understanding of history.
Yeah, like what if we find out life on Earth actually started somewhere else and got here somehow through interstellar travel?
Right. Suddenly the whole story of humanity gets flipped on its head.
We go from being this unique thing in the universe to just one branch on a giant, crazy tree.
And that's just the beginning. Imagine the technology we might encounter. Completely different ways of understanding physics, the universe.
It's almost too much to process. But it does make you think, right? Like, how would our values change? Our beliefs? Would it bring humanity together, or would it tear us apart?
It makes you question what it even means to be human.
Yeah.
Would we become more unified faced with this, like, cosmic wonder? Or would it just make our problems worse?
Such big questions. And you know, our document made a point that really stuck with me. Technology doesn't just exist on its own, it's part of society.
Yeah.
So even if we could travel faster than light, it wouldn't magically fix everything here on Earth.
That's for sure. All those social, political, economic forces, they'd still be at play.
Imagine the inequality. Would only the rich and powerful get access to faster than light travel?
It's a real concern. And what about exploitation? Could this technology be used to, take advantage of other planets or even other civilizations?
It's a lot to consider. We can't just ignore the ethical side of things when we're talking about such groundbreaking advancements.
Absolutely. This isn't just about exploring the universe, it's about the future of humanity itself.
We have to be careful. We have to be responsible.
It's about making sure everyone benefits, not just a select few, and making sure our pursuit of knowledge doesn't, destroy our humanity in the process.
That's a heavy thought. I think it's important to admit we don't have all the answers here. We're in uncharted territory, scientifically and philosophically.
That's what makes it so exciting.
It really is. It's like we're on the edge of something truly monumental.
It's the ultimate frontier, isn't it? That drive to understand, even when it takes us into the unknown. And who knows, maybe that pursuit will lead to even more incredible discoveries.
It's a good reminder that even if we never reach faster than light travel, just thinking about it can change how we see the universe and ourselves.
And who knows what the future holds? Maybe there I assess some loophole in physics we haven't found yet.
or some completely new technology we can't even imagine right now.
The possibilities are pretty much endless.
It's amazing to think about. Even if we can't physically travel faster than light, there's still so much we can do. We can keep learning about the universe. We can explore our own solar system, maybe even make contact with other intelligent life.
And let's not forget the power of imagination. Even if we can't actually go faster than light, we can explore those ideas through art, through philosophy, through stories.
It's a reminder that the human mind is limitless, even if our physical bodies aren't. So as we wrap up this deep dive, I want to leave our listeners with this thought.
Don't let what we know now limit what you can dream about.
Exactly. Keep asking those big questions. Keep dreaming big. And keep exploring this amazing universe we live in. Who knows what's waiting for us just around the corner? Wow, we've really covered a lot in this deep dive, haven't we?
From like mind-bending physics to some pretty heavy philosophical questions.
It's clear that faster than light travel, it's not just science fiction. It makes you rethink like the whole nature of reality.
It really does. And even if we never actually reach faster than light travel, just trying to figure it out has taught us so much about the universe.
It's true. It's like in the process of chasing this impossible dream, we've made all these incredible discoveries.
Yeah, exactly. Every time we learn something new, it just opens up more possibilities, more questions to ask. We don't have to break the speed of light to be amazed by the universe, you know?
That's a good point. I mean, look at all the incredible things we can do right now. The James Webb Telescope giving us these unbelievable images, rovers exploring Mars. We're even studying the echoes of the Big Bang.
It's mind-blowing. And who knows what's next? Maybe one day we'll find some loophole in physics that changes everything.
Or invent some technology we can't even imagine right now.
The possibilities are pretty much endless when you think about it.
It's exciting, but also kind of humbling, right? Like we're just this tiny species on this tiny planet, and yet we're capable of thinking about these huge concepts.
Exactly. Even if we can't physically travel faster than light, there's still so much we can do. We can keep exploring our solar system, maybe even find other life out there.
It really puts things in perspective. And, even if we can't physically break that speed limit, there's always our imagination.
Oh, absolutely. Science fiction, art, philosophy, they all let us explore these ideas, even if it's just in our minds.
It's a good reminder that even if our bodies have limitations, our minds don't. So as we wrap up this deep dive, I want to leave everyone with this thought.
Keep dreaming big. Don't let what we know now limit what you can imagine.
Exactly. There's still so much out there to discover. And who knows what amazing things are waiting for us just around the corner. Thanks for joining us on this incredible journey. Keep exploring, keep learning,